Let's go ahead and use our trig functions to find some missing sides and angles. Here I've got a right triangle. I've got a 57-degree angle down here, one side of 10 and one side of x. So let's see if we can find x here. Your first step, identify the angle you want to use. In this case, let's use this 57. Now, using this 57, let's see what sides we have. I notice that across from the 57, I've got my opposite side of 10. So let's go ahead and say I've got my opposite side of 10, and I've also got my adjacent side here of x. I've got my adjacent of x. Looking at the two sides I have, opposite and adjacent, I recognize that this goes with tangent. So I'm going to use tangent as my trig function. Now I could use cotangent, but we're going to be using our calculators here, and many of our calculators might not have the cotangent, cosecant, and secant functions. So let's go ahead and stick with our SOHCAHTOA. Let's keep it simple. In this case, opposite over adjacent is tangent. So to set this up, I've got tangent of my angle, always your angle. That'll be tangent of 57 equals opposite 10 over adjacent, which is x. Solving from there, let's get our x out of the denominator. So I multiply x both sides, and I'm going to divide by tan 57. That's going to give me x equals 10 divided by tangent of 57. This is going to be approximately 6.5. Now all of your calculators are going to be a little bit different with the cosine, sine, and tangent, but play around with these a little bit until you start ending up with the correct answer, and then we'll do some extra practice with this in class, and I can help you in person. Here we've got another triangle. I notice my angle is 24 degrees, so let's see what sides we have. First, I've got the adjacent here, which is x, so I know my adjacent side is x. I've got my hypotenuse of 16, my hypotenuse 16, so I know that because I've got my adjacent and my hypotenuse, I'm going to be using cosine. So let's go ahead and set that up. I get cosine of our angle, 24 degrees, equals adjacent over hypotenuse. Solving from there, I just need to multiply by 16. That'll give me 16 times cosine of 24 equals x. And if I multiply that out and round, I'm going to get x is approximately 7.1. Before we move on, I just thought of a very important calculator tip. There's actually two different modes in your calculator, degrees and radians. We're going to be learning some more about radians really soon, but for now, make sure your calculator is in degrees mode, or else you'll drive yourself crazy because you'll try all these kinds of ways of plugging it in, you'll keep getting the wrong answer. So if you see an RAD on the top of your calculator screen, make sure you switch that over to a DEG, which stands for degrees. Okay, moving on. In this triangle here, we have our two sides. We're actually trying to find what our angle theta is, but our process is going to be the same. So here's our important angle theta. I notice we have our adjacent side. So our adjacent is 21. We've got our hypotenuse right here. Our hypotenuse is going to be 30. And then, since we have our adjacent hypotenuse, we know we're going to use cosine, because cosine is adjacent over hypotenuse. Cosine, instead of putting an angle in here, this time this is going to be our variable, theta. So we have cosine theta equals adjacent over hypotenuse. Now how we solve for this theta here, a common misconception is people try to divide by cosine, but you cannot divide by cosine. Cosine is always a trig function based on the angle. So what we do here is we use cosine inverse. So we do cosine inverse of both sides. So cosine inverse of cosine, and then is going to equal the cosine inverse of 21 over 30. Our cosine inverse and cosine, those are going to cancel each other off, leaving us with theta On the right side, we plug this into our calculator, and we're going to get theta is approximately 46 degrees. If you're having difficulty finding the inverse trig functions on your calculator, look for a button that says either shift or second. After you push that, they should become visible. All right, I'll do one more if you insist. I spoil you guys sometimes. All right, we've got our angle theta, we've got our adjacent side, which is 5. Our adjacent is 5, and we've got our opposite side here of 13. Our opposite of 13. I know my adjacent and opposite, those go with tangent, so I'm going to get tangent of theta equals opposite 13 over adjacent 5. Solving from there, I'm going to get theta equals tangent inverse, because I'm solving for this angle here, tangent inverse of 13 over 5. Solving with my calculator, I'm going to get theta is approximately 69 degrees.